This is our video for Unit 7, Day 1. This will be the first video we do of the class in the new format, so follow along with your notes, follow along in the video, and get all your notes filled in. If you have any questions at the end, go over some questions and we'll do some practice in class. So this unit is going to be about congruence and similarity. So we're going to do today, the first day is just talk about what congruence means and what similarity means, and talk about what they mean specifically with triangles. We're all building up to doing some problems with triangles in the next couple units. So first thing is to define what congruent means. So we've already talked about congruent lines and congruent angles, so now we're talking about congruent shapes. Congruent figures have the same size and shape. Just like congruent segments have the same length, congruent angles have the same measure, congruent figures have the same size and shape. If two figures are congruent, you can move one so that it fits exactly on the other. Right, and by move, I mean you can either slide it, you can flip it, or you can turn it and get them to line up right on top of each other. If two triangles are congruent, we're talking about triangles mostly in this unit, they'll have congruent corresponding parts. That means all corresponding sides and angles. All corresponding sides and angles are congruent. The symbol we have for congruence is this equal sign with the squiggle over top. Right, remember what congruence means is equal in measure. So when we have that symbol in between the name for two figures, that means the two shapes are equal in measure. All their corresponding pieces are the same. So when two figures are congruent, to express that, we write what's called a congruent statement. Right, this represents that the two figures are congruent to each other. Also, the order is important on these. Because the order shows which parts correspond to which pieces. So go through a couple examples here. So first question is, are these figures congruent? Are these two triangles congruent? To be congruent, they have to have all sides and angles congruent. Right, so that's what we're going to look at. Which sides and angles are congruent? So first we'll look at the sides. So looking at the markings, I can see that side BC has the same mark as side EF. So they're congruent. I look at side AC, and that has the same mark on it as side FD. So those two sides are congruent. And the third, I can see that side ED has the exact same mark as side AB. So that's all three sides of each triangle congruent. So now we look at the angles. Right, for these angles, since there's no confusion, I can just use one letter. So I look at angle C, has the same mark as angle F, so they're congruent. Angle B has the same mark as angle E, so those are congruent. And angle A has the same mark as angle D, so those two angles are congruent. So all six pieces of both triangles are congruent, so the two triangles are congruent. So now the second part of this is to write a congruent statement. So when you write the congruent statement, the order is very important. The order shows which pieces correspond to which pieces. So if I look at the angles, it's the easiest to tell. I see that A corresponds to D, that B corresponds to E, and that C corresponds to F. So to name a triangle, I use a little triangle shape to represent that's a triangle, and then I use all three corners to name the triangle. So we can start off with any order. I could call it ABC or CBA or BAC or CAB, whichever you want to do, as long as you match that same order with the second triangle. So if I start off calling it ABC, I start off with the point that corresponds to A. Since A is first here, D has to be first over here because D corresponds to A. Same thing, B is second, B corresponds to E, so E should go second on the second triangle, and C is third, which corresponds to F, so F is the last point. So this is my congruent statement right here. Triangle ABC is congruent to triangle DEF. Right? Putting it in that correct order shows you from that statement which pieces correspond on each triangle. So on the second example, we have the opposite. We have a congruent statement already, triangle CAT, congruent to triangle DOG, and from that statement, we can list all the pairs of congruent sides and angles. So start with the sides. Sides are segments, so to name a segment we use 2 points. We use the endpoints. So the first side from the first triangle would be side CA. Right, and we're going to match the order. So CA is the first two, 1 and 2. So we use 1 and 2 from the second triangle, DO. Same thing, the next out the first triangle would be AT, and that would line up with OG off the second triangle. And the last one would be side TC off the first triangle, would be the last side, be congruent to GD. Alright, so these are all three sides. Remember, sides are segments, so we name them with the two endpoints and the segment sign over top. For the angles, we can just use one letter. And again, the order is important, so if we start with angle C, that's going to be congruent to whatever's first in the second triangle, which is angle D. Same thing, angle A, congruent to angle O, and angle T, congruent to angle G. So the order is important. We have to write these congruent statements so the order lines up, so that from the statement we can tell which pieces on one triangle match up with those same pieces on the next triangle. So the other topic we'll talk about in this unit is similarity. So this isn't congruent figures, but similar figures. So similar figures are proportional to each other. So ratios and proportions are what we talked about back in Unit 4. So if you still have your notes from Unit 4, you can look at that for any help with proportions. So similar figures have the same shape, but they're different sizes. What this means for triangles is that all the sides are proportional and all the angles are congruent. Right, so it's like a scale model. So all the sides are the same ratio. They're just either bigger or smaller than the original by some factor. And the angles are exactly the same. They're congruent. They have the same measure. So when sides are proportional, that means that the sides on one triangle are going to have the same ratio to their corresponding sides on the other triangle. So they'll all be half as long as the other triangle, or 3 times as long, or a third, or 3/4. It just has to have the same ratio between the sides. And remember that ratio is just another word for fraction. Right, so our sides are proportional, they have the same ratio, but all the angles have to have the same measure. They have to be congruent. Just like with congruence, we can write a statement for similarities called a similarity statement. Right, and just like with a congruent statement, the order matters for a similarity statement. It shows which pieces line up. The symbol for similarity is the same as the symbol for congruence without the equal sign. It's just a squiggle. When two figures are similar, that common ratio between their side lengths is called the similarity ratio. So we're going to look and see if these two figures are similar. If they are, we're going to write a similarity statement. So first I'm going to check the angles. Remember that the angles for similarity need to be congruent. So you have to have the exact same angle measures. So look at the marks, the way the picture's labeled. I see angle A is congruent to angle X. Angle B is congruent to angle Y. And angle C is congruent to angle Z. So all my angles are congruent. So that's the first piece of similarity. Second piece, I need all the sides to be proportional. Right, so look at the first side. Look at the first side off the triangle on the left is side AC, and compare that to the corresponding side on this other triangle. Right, we look at A lines up with X and C with Z. So look at side XZ. Right, and I see that that ratio is 2/4, which is 1/2. So do the same thing with the other two sides. Look at AB. Right, A and B line up with X and Y. So look at that ratio is 4/8, which is also 1/2. And the last one, I'll look at the last side, BC, which lines up with YZ. Ratio between those is 5/10, which is also 1/2. So all three of these are proportional because they have the same ratio. Right, this is called a common ratio between the sides. And for similarity, this is called the similarity ratio. The ratio between all the sides is the same. It's all 1/2. So these are similar. So for writing the similarity statement, we need to line these up in order. So see that A corresponds to X, B to Y, and C to Z from looking at the angles. So whatever order I start with on triangle ABC, I have to match that same order with the second triangle. So you say triangle ABC is similar to triangle XYZ. Right? You could also say triangle BAC is similar to triangle YXZ. As long as the order between the two matches, it doesn't matter. As long as it shows that B corresponds to Y, A to X, and C to Z, you can use any order you want, as long as they're both written out in corresponding order. So last example, we're going to take a similarity statement and figure out which angles are congruent and which sides are proportional. So remember, that's my definition for similar triangles, that my angles are all congruent and the sides are all proportional. So we'll start with the angles. So again, it's written out in the corresponding order. So I have RDU, 1, 2, 3, similar triangle PTI, 1, 2, 3. The 1's correspond, the 2's correspond, and the 3's correspond. So I can say angle R, the first one on the first triangle, is congruent to angle P, the first one on the second triangle. Angle D is congruent to angle T, they're both the second, and angle U congruent to angle I, they're both the third. For the sides, I can show that they're all proportional. So if I take the side RD, that would have the same ratio. That would line up with PT, have the same ratio that DU would have with TI. It can also be the same ratio that UR has with IP. Right, these are all the corresponding sides. All the ones on the top are sides off of triangle RDU, and all the ones on the bottom are sides off of triangle PTI. So that's why the order is important with our similarity and congruence statements, so we can see which pieces correspond. We have to put them in the same order. So match up the points that correspond to each other between the two triangles. This is the last piece of the notes for today. It's the triangle angle sum. So hopefully this is something you've seen before. If we take the measure of the three interior angles, right, so angles inside of a triangle, always, measure of those angles always add up to 180 degrees. Right, and this is called the triangle angle sum. We take the angles in a triangle, sum means add, we add them up, we get 180 degrees. Since there's three angles, we have to equal 180 degrees. That means a triangle can have at most one right angle or one obtuse angle. So if we had two of those, it would be over 180 degrees. Triangle that has a right angle is called a right triangle. Triangle with one obtuse angle is called an obtuse triangle. And a triangle that has all acute angles is called an acute triangle. So we can classify triangles by the angle measures. We can also classify them by their sides. If all three sides are congruent, that's called an equilateral triangle. all three angles in the equilateral triangle are also going to be congruent, right? And they're going to be 60 degrees, right? And the way we get that is we take our 180-degree angle sum, divide it into three equal angles, and that gives us 60 degrees. Triangle has two congruent sides. It's called an isosceles triangle. So the angles across from the two congruent sides in an isosceles triangle are also congruent. So if we have three congruent sides, we have three congruent angles. Two congruent sides, we have two congruent angles. These are called the base angles of an isosceles triangle. So that looks like if we have an isosceles triangle, it has two sides that are the same, and the angles that are across from those sides are congruent. These are called the base angles. If a triangle has three different length sides, that's called a scalene triangle. If it has three different length sides, also has three different angle measures. So it has the same number of congruent angle measures as it does congruent sides. So for the last piece of your notes, what we're going to do is three things. First thing is we're going to find the missing angle. Right, so all these have one angle missing. Then we'll go back, we'll say whether the triangle is acute, obtuse, or right. And then at the end, we'll go through and say if it's scalene, isosceles, or equilateral. So three parts for each one. So first thing, I'm going to find the missing angle. So all three angles should add up to 180 degrees. So for the first triangle, I have a 50 plus a 50, so I have 100 degrees. So to find the missing angle, I'm going to take that 100 and subtract it from 180. That leaves me with 80 degrees. Same idea for number 2. I have a 60 and I have a 60, so I have 120 degrees. Now I'm going to take that 120 degrees and subtract it from 180 to see what I need to make the triangle angle sum, make 180 degrees. So that's going to be 60. This one down the bottom is going to be the same thing. So I have a 30 and I have a 20. So total, I have 50 degrees in this triangle. So I need to figure out what more I need to get up to 180. So subtract 50 from 180, I get 130. And that's going to be my missing angle. So that's the first part, is the triangle acute, or is what's the missing angle in the triangle, what we need to get 180. Now we're going to go through and say if it's acute, obtuse, or right. So number 1, we look at the angles. 50, that's acute. 50, that's also acute. 80 is also acute. So number 1 is an acute triangle. 3 acute angles. Look at number 2, all 3 angles are 60, so that's also an acute triangle. All 3 angles are acute. Look at number 3, we have 30, that's acute. 20, that's acute, but 130 is bigger than 90, so this is an obtuse triangle on number 3. The last piece, we're going to say whether it's scalene, isosceles, or equilateral. So on number 1, we see we have 2 equal angle measures, which means that we have 2 equal sides. So this is an isosceles triangle. On number 2, we have 3 equal angle measures. So we're going to have 3 equal sides. So this is an equilateral triangle. Now on number 3, we have 3 different angle measures, means 3 different sides. So this is a scalene triangle. So what we'll be doing in class after this is practicing writing congruent similarity statements, identifying congruent similar triangles, finding missing angle measures, and also classifying triangles as acute, obtuse or right, scalene, isosceles, equilateral. If you're looking for extra help with this or want to find other videos that could be helpful besides this one, on YouTube, you can search for videos on congruence and similarity for triangles, and also for this last one, triangle angle sum. If you're not understanding this, you can search for these things on YouTube, or you can go back, look over the notes again, rewatch it, go back and pause, whatever you need to do. You have this video, you can find these resources also online if you search for them.